Hi, for our senior design project, we built a stealth multiplayer battle royale video game called Nightwatch that we're excited to show you today. To begin with, this is a really quick, compressed overview of our video game. Okay, so in Nightwatch, you play as an assassin dropped into this densely populated world filled with several innocent civilians, but among them are other assassins playing online. But the issue is everyone in the game looks similar, so all the other assassins are hiding in plain sight. Stealth and observation are two very important parts of this game. You have to look at the people around you and see who's acting different. You also have to make an effort to be as stealthy as possible and blend in with the crowd. Right there, we saw another character, the one in red, run, in an area where everyone else is walking. Maybe she saw us approaching, or maybe she just did it by accident. In any case, we have to pursue, but always do so stealthily. At the start of the game, every player is assigned a target, and the blue compass fills up as we get closer to the target. I lost her for a second there, but we're back and, following our target. Okay, skipping ahead a bit, we did not approach her stealthily, and she found us before we found her, and she's chasing us right now. She currently has the upper hand. Let's try disappearing into this crowd. First, I throw a smoke bomb. Then I'm going to swap outfits with someone else in the crowd so she doesn't notice who I am. So each outfit swap only lasts a few seconds, so I have to do it again before she catches us. There she is, running up the stairs. If we've done this well, we can sneakily escape right now. There we go. I don't think she spotted us. Okay, so for the sake of this demo, let's look up and see who she actually ended up killing. Did you see that? She killed someone with a similar outfit to mine, but an NPC instead. And there, she's doing it again. Okay. I just switched outfits again. And now I'm going to try to get the drop on her, basically. There we go. Yep. And yeah, we killed her and won the game. That was a quick demo of Nightwatch. Hope you enjoyed it. Okay, so next up, we want to give you a quick technical overview of our gameplay and how we implemented some of the things like our crowd, our abilities, and our multiplayer systems. So, inspired by games like Hitman and Assassin's Creed Unity, our crowd system is based on three fundamental subsystems. Firstly being spline paths, secondly hotspots, and thirdly panic mode, all three of which we're going to get into very soon. So, let's start off with spline paths. So spline paths are predefined curves that we place all over the map and generate crowds at every point in the path. This simulates the more orderly nature of crowds. Like at Penn, for example, when we get to class, we may have very different classes, but we're always traveling down the right side of Locust Walk and coming back on the left side. So this kind of simulates that orderly behavior. However, to make it more realistic, we also add a bunch of noise to simulate how people tend to attract and repel each other in large crowds of people moving in one direction. This draws from a lot of the ideas in the flocking Boyd's algorithm, which shows how organisms tend to attract and repel each other in 3D. So next up are hotspots. And hotspots can be thought of as places that people go to that depart from their general routine. Right now, we see a bunch of people crowding around this bazaar, for example. We have several hotspots like bars or street performances, and these generally present very good places for players to blend into crowds. So, for example, a player might walk into a bar and pretend like, they're chatting with another person there. Next up are stationary crowds. So unlike our previous crowd examples, these are the least performance intensive because they're just stationary crowds performing a default animation, but they're some of the most useful crowds to get lost into as a player. So once you assassinate someone, you can easily just lose yourself or your pursuers inside of this crowd. And because they're not that performance intensive, we can afford to have large crowds like this that add to the claustrophobic atmosphere of the scene. However, if you run through these crowds, they start moving and bumping around, and you begin causing a scene, which attracts more attention. Technically, all of our crowds are implemented as game objects that have dynamic physical interactions with each other and switch from state to state. Next up, we have panic mode. Panic mode is triggered when a certain assassin runs into a crowd and kills someone in the middle of a crowd, regardless of whether they're a civilian or another assassin. We want to enforce the idea that killing someone in a non-stealthy way has its consequences. We do this via a system called panic mode, where if you kill someone, you emit a certain noise that other NPCs can hear, and that noise results in them running away. When they run away, they follow flow vectors that are placed on the ground that ensure that they move away from you as fast as possible. And we can turn up the noise sensitivity level in order to make more people freak out whenever someone dies. On a broader technical note, we implemented this entire project in Unreal Engine via the blueprints and the C++ system. All of our crowd abilities and gameplay attributes are built in a way that makes them very, very, very easy to modify and change for future testing. We've also allowed the game to be extremely scalable so that it can run on any platform from a mobile device to a high-end, next-gen console.
Are exploring the server manager that we created to manage servers and interact with AWS ECS. So here we have a request that the client would perform to get the current IPs of each server. So we do this GET request, we can get the IPs, and along with the number of users in the server and the maximum users. Then, pretending that we are a server, we can communicate to the server manager and let them know how many users we have. So here we'll say we have 1 user. And this is recorded as successful, and then we can request again the IPs, and we have a new server that has come online. Here on the ECS console on AWS is where our game servers are allocated and run according to an API interaction that we have with the cluster. The cluster is the core unit of Amazon ECS, so we have our multiplayer stealth cluster right here, which is responsible for a service, which in this case is running our main server. Now to scale up and down the number of servers that we run, we change the number of tasks. So this service is responsible for deploying tasks, and we can tell the service to increment or decrement tasks. Looking at an individual task, we see here that we have a IP address that we can connect to, which we'll do so shortly, but the container uses a base image that has all our dependencies, and then we're able to download the game server and ultimately run it.